All right, all right. Here we go. Here we go. Another live. You never know what's going to happen. I love it. All right, everyone. This is an unscripted live session where we are going to cover polarity and medical equipment because I either have questions that people keep asking me on this stuff or I see technicians that are still doing some things wrong. So today we're going to cover polarity and medical equipment. So I have a bunch of different examples here and some things to look out for, some stuff that you're now going to be aware of now on the job. And we've got a little experiment here with some isolation power. So let's get right into it, guys. Let's cover polarity in medical equipment. So what exactly am I talking about? Well, let's take a look. I have, what is going on with my camera? Okay. Hey, bud, what's going on? Hey, food's on the way, okay?
Yeah.
Okay, so go on. Go get the food.
Okay.
All right, thanks, bud. All right, here. I'm going to move this camera for just a moment, guys, because I need you guys to see this whole entire board. Right? Is that good? All right. All right, guys. So let's go over polarity. I hope this isn't blasting out the camera, is it? All right, that's good. So one of the things that I'm noticing is that people, when they wire up a medical device on the inside of your IEC connector, which is your little connector, it looks, I don't know, kind of like this. You got your blades. Now this is in America, guys, so be kind to me. So you know that you have your hot, neutral, and ground. Well, this is what your female end of the cord is going to look like. And of course, I don't have any examples here because why would I, right? Preparation's key. Anyway, research it. There we go. So this is your IEC connector, all right? So your cord end is going to look like this right here. It's IEC, International Electronic Something Standard. But this is your female IEC connector, which is going to be on your plug end or on your cord end. On your receptacle, which is on your medical device. Do I have an example of that? I thought I did. Anyway, who cares? Your polarity is your line and your neutral, or in some countries it's going to be L1 and L2, you know. So it's going to be your connections that are going to secure your neutral line and your ground, okay? So this guy down here is going to be your ground. And you guys have probably seen some of these if you're in America. I hope not, because these guys here are the devil. And we're going to go into that, all right? But notice that these here take a 3-prong ground and they convert it over to a 2-prong. All right. If you guys have these in your house, get rid of them. Okay. I see people use these darn things all the time. Just get rid of them. And this, what we're going to cover, is also going to be the reason for why, if you see a cord, a plug end in a hospital without your ground, all right, if you see it sheared off, why you need to get rid of that bad boy immediately. See, this is a perfect example, this one that I just yanked out over the wall right here. We'll go over that in just a minute. Anyway, I know I'm jumping around. Guys, I'm trying not to. I swear to God, I'm trying not to. But that's your IEC, and that plug is designed to maintain your polarity. We have yes, both of these. So you guys have probably seen these guys before. This is a polarity or outlet checker, and this guy here is a different version of it. It has different LEDs that will light up on the end. Maybe they're not LEDs. Maybe they are, the hell they call them, fluorescent, mini fluorescent bulbs. But anyway, it's just the same thing. You plug it into an outlet. It tells you based on the light output what the polarity and what the outlet is wired for. Okay, you can see my lights here on the back. We'll talk about those in just a moment. But the reason that we want to talk about polarity in medical equipment is because you have your little IEC connector, this little guy over here. Let's see. I guess that's as good as we can do it, right? So your IEC on most devices, you have hot, which goes through, and then you have your neutral, which is normally not switched, okay? So a lot of these things here, and this here goes through your circuit to your load, or let's do a light bulb. Let's do a light bulb, all right? Okay? And this here is going to be our load. All right, I understand that this is going to be backwards. We'll work with it. Okay, so this here is your power switch. This here's your load. This one here is connected to hot or line. This one here is neutral. In America, it's neutral. I don't know how it is anywhere else. Okay, so guys, this is the problem, all right? The reason polarity is so important in medical equipment is because your switch side and your line side, your neutral side, if you take a look at this, your whole device is going to be wired with ground to here. Okay, so you have a lug inside your device that's going to be grounded. You're going to have neutral, which is going to go all the way through the device up until the switch, power switch. And then hot is going to be the shortest. It's going to be the shortest power cable in your entire device. And normally your power switch is right next to your power switch. Oh, geez. Your power switch is going to be really close to your IEC power input to your medical device. Okay, so even though I drew it way over here, it's usually going to be really close because you don't want hot wires running throughout your whole device. And this is why polarity matters. Okay, so let's say you switch these over, and now this right here throughout your whole entire device is going to be hot. All right, here, let me see if I got some red. Got some red. And this guy. All right, some of you guys already know exactly what I'm going to say on this, so good for you. That's actually a good thing. That's a really good thing, actually. So let's say okay, and I'm going to do it just like I said. Our power switch is here, and then here is your load. So let's say you have reverse polarity, okay? So this one here. So now your entire device is hot on the inside, and only this little line right here is going to be neutral with reversed polarity. And what I mean by that is that you take this wire and this wire in your electrical cord when you wire it, like this guy right here, and you reverse those two wires. Or on the inside of your device, when you have your spade connectors that connect to the back of your IEC outlet, you will reverse them when you reattach them. Whenever you detach electrical wires on the inside of your medical device, try and take a photo if you don't remember which side is line and which side is neutral, because if you reverse them on the inside of your medical device, then all these other safety features that are all the way back to the power pole, there's so many safety features that are built into electrical code. If you fail to connect those two wires on the inside of your medical device in the correct polarity, you just negated every single one of those safety features that is built your standard electrical code. Okay. Hold on. So the bad thing about all this is if your entire device is hot and your your power switch here is now reverse polarity and it's neutral, then that means you could honestly zap yourself by even touching this device. So let's say you have an electrical short where there's a wire inside the device and it shorts itself to the chassis. Okay, and this is going to go right into these guys. All right, so these guys right here, the whole purpose to these things being a pain in the butt is because you are taking away your ground, and you can see right there. So if you have an electrical short inside your device and you get rid of your ground, you're counting on neutral carrying away all that crazy current, which it can't do. All right. So you, the person, is here. You touch the ground, you are at ground potential. Okay. Boop, boop, boop. The chassis is supposed to be at ground potential. All right. But it is not, because somebody got rid of this little ground right here using a cheater plug or on a cord. See this cord right here? If this ground is broke off and somebody plugs it in upside down in a receptacle, you just negated all that electrical safety up until the point of the user. All right. I have seen this where you have a power strip and you have only so many outlets on the strip. And when people go to plug things in, you know, it doesn't quite fit. So sometimes people will snap the ground lug off and they'll put it in upside down. Guys, you just bypassed all your electrical safety code. All right. And you are gambling at that point. All right. This is a very, very serious problem. All right. Polarity does matter. On your plugins, when you're wiring these things, black to brass, or it's your ass. That's the phrase that electricians use, because if you flip these over, I want you guys to notice. Hold on, let me get this down close so y'all can see. Let's get you guys in nice and friendly like so that you can see what I'm talking about. Take a note that on these 3-prong plugs, the size of this blade and this blade are often the same, because you're relying on the ground, your 3rd prong, to determine which way you plug it in, right? Because you can't plug it in upside down. So when this guy is gone, these 2 blades right here are the exact same size. You see that? Take a look at this cord right here. Same exact thing. If I were to rip off this ground right here, I could plug it in upside down. And now we have a possible live chassis, which means you walk up and you touch the medical device and you could get zapped, right? So the whole purpose to maintaining your polarity, oh, somebody's been playing in my markers. Let's get rid of this guy right here. Whoop. All right, let's start again. So let's say we have our power in over here, all right, with our 3 blades. And like I said, your line is going to run over to a switch, all right? Now in lots of medical devices, I can't say all, but in lots of medical devices, line and neutral are switched. So in one of my other videos, I talked about double pull, double throw switch, or double pull, single throw. Okay, a double pull, single throw is the power switch on many medical devices. Let's see if I have one right here. I have so many. Hell yeah, I do. That's what I'm talking about. Okay, well, this one is not a double pull. It is a double pull, but it's single throw. Okay, so a double pull, double throw is when you have a middle position and you flip it one way and that reverses the polarity, or you flip it this way and it changes, you know, the direction of the wires. See that? So this is a single throw because it goes boop, pops over in one direction only. It's on or it's off. All right. It's a double pull because you have both line and neutral, which are being switched. Normally the middle is common. Okay. So when you flip it off, it's going to some open conduit, open connections here. When you flip it to on, it makes these two right here connected. All right. So this is a traditional power switch used in medical equipment. Okay. Maybe you guys can see it a little bit better there. So this type of power switch right here is what we usually find. And that means that both your line and your neutral are cut off when you hit the power switch. But that is not always the case. We'll go into that in just a moment. So what we like to see is in your medical device, do L for load, up here, and this guy here. Draw this guy here down to ground. Okay. And then your chassis here is also grounded, technically. So this right here, we're going to do line, and this one here, neutral. This is how we like to see our medical devices. Okay, we like to see the neutral be the side that goes throughout the device. There's no current on this wire whatsoever because it's open, but it's also not at a potential. Potential is the key word because the chassis and the internals of the device are at the exact same potential. Now imagine this. Imagine that we reverse the polarity of your plug end, okay, or one of these, or on the inside of the device, you accidentally flip these two wires around. It can and does happen, guys. That's why I'm saying always disconnect wires and reconnect them exactly to the same exact poles that you disconnected them from. Let's say you wired this guy wrong when you put a cord together. What could potentially happen? Okay, so on a reverse polarity, we have line and we have neutral. Okay, so now we have 120 volts in America. Even though there's no current going through this whole entire thing right here, we have 120 volts sitting on all the electronics throughout the whole entire device. So what happens when you're working on something when it's plugged in? That never happens, right? On a reverse polarity, let's say you accidentally touch the outside of the case and you touch any single component on the inside of a circuit board. Right? So let's say normally this thing's plugged in, but you know, if I had a power switch here, you would assume that this guy's powered off. Now this is a power supply, so I would never be goofing around with it openly like that. But let's just say that you touch the case and you accidentally touch anything inside it, even though the power switch is off. You, my friend, are going to get lit up. Okay? And the reason you're going to get lit up is because there is a potential between the internals of the device and the chassis, or yourself. You, remember guys, you are at ground potential, right? So you are supposed to be at the same potential as the case. So even if there's no electrical abrasions or anything that light up the case, you and the internals are at a different potential. So you will still get zapped. All right, does that make sense, guys? You guys feel free to go ahead and ask me questions about this later, because this video is going to be viewed probably hundreds of times in the future. And I just want to get this clear to everybody that polarity is so important. But I'm going to throw a rock into the machine. All right. Let's say we go one step further. This guy right here. You can see my little transformer up to the side. Now, in a normal device, let's see, can I get this so that y'all can see it? Yes, absolutely. From voltage, AC. So in a normal device, if I go from line to neutral, you can see right there, I got 123 volts I know it's reversed. Can't do anything about that at this time. So let's say I go from the line side to ground. What do we see? I see 123 volts. Line to ground. That's right, guys. Neutral and ground on a traditional electrical outlet, like right here, you will have technically nothing, right? Technically nothing. I got what, 0.28 of a volt, something at best. So not very much at all. Hey, big girl. But this guy right here is separate. It's special because this one is on an isolation transformer. And I know I keep bringing up isolated power in a lot of my videos, guys, because in a medical facility, this helps you understand what's going on here. All right, so let's take a look. Across both poles, I have, what, 128 volts. That's excellent. Let's move one of these guys over to ground. What do I have? I got 34 volts. Woo. That sounds a little crazy, huh? Let's move to the other pole. What do I have? I have 32 volts. Thank you, bud. I appreciate it. Yep, I know. So what's going on? Well, in a traditional outlet, from one prong to ground, from line to ground, I will have 120 volts. And from neutral to ground, I will have 0 volts. On this one here, on isolated power, between the two prongs, I have 120 volts potential. But between this prong and ground, or this prong and ground, I should have about 60 volts. Why is that important? Well, I've got a whole video set aside on isolated power and what's going on with that. All right. So I'm not going to cover isolated power in this one, but I do want to show you that there is voltage on both line and neutral. Okay, that's very, very important because that is going to bring us into medical equipment, specifically medical devices that are probably going to be in and about a wet location or an operating room, right? And that is what we have right here. These are medical grade power supplies, and one of the easiest ways to figure out if something is a medical grade power supply is try and buy it. Because believe it or not, medical grade power supplies are some of the hardest things to get because manufacturers almost never want to sell them to anybody. Here is one of the major things that's going to stick out on a medical grade power supply. You see this right here? I have 2 fuses, and that is so convenient because one fuse is going to go to line and one of them is going to go to neutral. Both line and neutral are fused when it comes to a medical grade device. On most of them, anyway. I can't say that for all of them, but here in America, most of them. And take a look down here. Let's see if I can get it up for you guys. You see this little brown round thing right here and right here? Yep, those two. Those are both fuses. You can still repair this if anything happens. You can replace those, just like, you know, these two here are replaceable. So line and neutral on this guy as well are also fused. I mean, not only does it have the Faraday cage right here, you know, that's kind of a big indicator as if it's got a metal cage surrounding it for RF noise, because we don't want any RF noise getting out into the environment around EEG or around EKG systems or anything. So there's a lot of shielding in a medical grade power supply, but chiefly we have line and neutral fused. And the reason that we do that is because of this guy right here that I showed you. We have voltage on both line and neutral, which is not normally the case. If you take a power supply that is used in a, see, I know I got a few of them around here. Oh yeah, I'm going to tear open a couple of those things very soon, guys. If you take a power supply that is non-medical grade, you will most likely only have one fuse, okay? And it's only going to be on the line side, not on the neutral. All right, so a medical grade power supply, line and neutral are going to be fused. And power switches, guys, we have line and neutral on many, if not most, medical devices. Line and neutral are going to be switched. So we disconnect all the power from the entire unit because human error. People can always accidentally snap off the ground, plug it in upside down, whatever. So we want to kill both line and neutral so we don't end up with that situation like I showed on the whiteboard where we have line power running through the device even though the power switch is shut off. It can happen. Medical devices have such special electrical code, and once you get into it and you start really paying attention to how much detail they put into the design of medical devices, you really get to appreciate all the thought that's gone into these devices and why we're special. Okay? Oh my goodness, guys. I am probably going to let you guys go right there. This is going to be just a short video on polarity. It's extremely important. If you have any doubts, keep something like these guys right here in your tool bag. I have something like this in my tool bag. You just plug it in real quick. If there's any doubt whatsoever, if your medical device is acting up, which I have seen before, if it's acting up, plug in a polarity checker and check it real quick. Or use your fancy dancy multimeter and make sure that you are seeing the correct voltage on the correct pins. And never ever assume that something is wired correctly. If it's plugged in, always assume that every metal surface is hot, okay? Because you never know if there's a wire in there that got pinched, which I have seen so many times. If there's a wire in there that's pinched and you have a really poor ground, I mean, that happens all the time on medical equipment. We abuse stuff like it's going out of style. If you have a really bad ground, but here you've got a pinched cord, well, guess what? Your entire chassis could be hot. It could be, and in fact, probably is. So always assume that something is hot and live. And remember, guys, that just because it is unplugged doesn't mean that it's safe, because most larger medical devices have battery backups, and batteries are way more dangerous than all this. But what I'm saying is when you disconnect something, make sure you connect it exactly back to the terminal. Pay attention to your labeling. Almost every single medical device is labeled. What is neutral? What is line? What is hot? Pay attention to your labeling and put it back where you found it, because even something as simple as a switch, reversing your line in neutral could be absolutely devastating. Not to you, but perhaps to your patient. So guys, that's all I got for you. Pay attention to your polarity. If you see these plugs in your medical facility, you need to get rid of them ASAP. And just to let you know, these are the last two that I have here in my house, and these ones are also going to be gone. If it wasn't for me wanting to make a video on polarity someday, these things would already be gone, because there is no reason in a modern house to have a cheater plug. All right? Y'all have a wonderful afternoon. Thank you for stay tuned, guys. I know this was a short video. It's only 28 minutes long, but I just had to get that off my chest because I still see people wiring these things wrong, and or they think it doesn't matter if the ground is snapped off, and it just drives me absolutely crazy. So guys, thanks for watching.